Very good morning, guys. We're back with another problem of linked list, and this problem is basically the addition of two linked lists. So it's a medium level problem, and it has some certain constraints like the space and time complexity, which you have to keep in mind. And I've written the problem statement into three parts. First, I have divided that given the algorithm, then the pseudocode, and then the source code for better understanding of this problem's statement and multiple phases. So what we can see is we will be given two numbers like 3, 4, whatever the numbers are. And say for example, n equals to 2. So this n doesn't represent any number. This represents the number of queries. So total number of lists you want to have in your total number of lists. Make it very clear n does not represent any what do you say, n does not represent any size of the list. N represents the total number of queries which you want to run on your code, and num1 and num2 are the two separate lists. And if you see num1 and num2, they are taken as 45 and 345, but you have to break it in the form of a list. So 4 comma 5 and 345 will be like 3 comma 4 comma 5 and null. So you can very clearly see that in case of m equals to 3, n equals to 2, it is basically saying that the size of the first, so it's not the queries, it's basically saying it's the size of the first. So in order to understand, and the m equals to 3 is saying the size of the second list with the 3 elements, right? So if you take the second example, if this is 4, so there are 4 elements, and this is 2, there are 2 elements, and the output is 2. So basically what we have to do is 345 plus 45 will become 390, and 390 can be broken and it's written like 390 and null. This is how you're adding the two linked lists. If you see the driver code, what they have done is they make a constructor of the node class. Then there is a driver code which is n is taking from input. Okay, number of test cases IMT is sc.next val has been also taken, a num told num nail and also be done, and lastly they are taking a solution g when taking two lists to add and print the list. Okay, so let's not go for that. Already the class node is given over there. So for understanding, I've written the algorithms over here. So if you see, first we have to reverse the input linked list, define a function reverse that takes a linked list as input and reverses it. Okay, this function will be used to reverse both num1 and num2 linked list. So we have to take the two linked list and then eventually reverse the linked list, add the reverse linked list in add to list functions. We have to even add the linked list, then reverse both the num using reverse function, initialize the vary sum to store the sum of the digits and carry respectively, and iterate through the linked list, set some value, num1 is not there. Okay, pseudocode is also there. Function, we have to take reverse previous equals to null, current equals to null. While current is not in null, then a loop will be done. Next function, the add to list. Okay, and function add to list and answers. Okay, so here comes the source code. So in the source code, what we have done is we are just taking a reverse function. Okay, let me just execute this source code so it will be easier for us to understand. Yeah, so if I come over here, this is my class solution. So I have to very carefully understand what is done over here. Okay, before I come to the node reverse, I have to come over here because adding to list. So this answer list is a dummy list which is used to store the result. Be very carefully note this, that the answer of the dummy list is used to store the result. Now we have taken the pointer. Now we have initialized the node and we have created the object of the node as answer. And now we have initialized another head1 h1, which is the pointer to the head of the result location. Now we are doing what? These values 45 and 345 are stored in num1 and num2. We are going to reverse it. So when we are reversing it, we are writing reverse comma reverse in quotation in brackets. We are going to pass the values of num1 and num2. So num1 and num2 is like 45 and 345. We are going to pass it here. So initialize carry to handle addition and carry equals to 0. Okay. So one thing like whenever we do addition of two elements, we don't need the carry variable. But if you mathematically think, like whenever you are doing it like in your hands or in your palm or whatever the calculation you use to do the mathematics, so it's like 4 and 9 is there. So obviously like 9 plus 4, how are you going to do 9, 10, 11, 12, 13, right? 9 plus 4 is 13. So you put 3 and then 1 is your carry, which is added to the next variable, to the next adjacent digit present. So that's how you do basic maths from childhood, right? So similarly, what we can do is we are taking a carry for taking the count of the carry. Now we are iterating through both the list while they reach the end or the carry is 0. So the constraints are num1 not equals to num. Means num1 or the first list cannot be null till that time we have to execute the loop. Num2 not equals to null means also that the second list cannot be null till that time we have to execute. And lastly, the carry not equals to 0. So if the carry becomes 0, then there is no need of further addition, because we know that the carry is signifying the extra digit and then adding it over there. And then lastly, we have to do end sum equals to carry to initialize the sum with the carry, right? So add the current digits of num1 and num2 if they exist. So if num1 not equals to none, then sum equals to sum plus sum is a variable which stores sum. So basically, whenever we used to do in previous coding questions like sum equals to sum plus num1, it means that adding the value of num1 to sum. Okay, and sum is always written over here because it is storing the previous sum as well. So num1.data signifies the data stored in the current node. So if this would have not been a linked list, I would not have written this data keyword over here just because it's a linked list. So I have to put data over here. And I can't just do this question without creating the class node. So the class node over here, although it's comment and it's obstructed, but it is also been given in the driver code. So be very careful about the class node, because class node is used to initialize the data which has been used over here, and over here. Similarly, what we are going to do is we are going to add the current digits of num1, and similarly for the num2. Lastly, we are going to create a new node with the sum of the current digits. Yes, answer equals to new node sum modulus 10. Answer equals to ans.next. Move the result pointer to the next node and carry sum equals to update the carry. So now you will ask me a question, why I am doing sum modulus 10? So whenever we are doing sum modulus 10, we are automatically modulus what? Modulus gives the last digit. If you remember in digit breaking calculations, we use modulus digit equals to digit modulus 10, then sum plus equals to digit, and then number byte equals to 10. Similarly, we are doing carry equals to sum by 10 to update the carry for the next addition, and answer equals to answer.next to move the pointer to the next answer node. And lastly, reverse the result list again to get the cut, because since why we are using the reverse function to again reverse the list, over here we are also using reverse, then again why we are using reverse, because whenever we are getting the ordered list, we are reversing it to increase our time complexity, to decrease our time complexity, because whenever you're reversing something, it's easy for many ways. It's easy to do it, like it helps in calculation output and iterative applications, and it helps a lot, right? Similarly, whenever you're doing the reverse h1 equals to reverse h1.next, because we have already destroyed over here, we have already destroyed the order of the list. Now we again have to make it back to the original format. So original format, that's why we are reversing. Lastly, we are removing any leading zeros from the result. That's why if any leading zeros are present, how we will find any leading zero? So what is basically leading zero is, leading zeros are the zeros which are present in the front. So if you see in this case of the example over here, the answer is 7 and 0, right? But if you see 63 and then 0, you very clearly see the leading zero means the zeros in the front, but whenever giving the answer, you don't have to give the zeros. Similarly, we are removing the leading zeros like that. Lastly, we are returning the head of the resulting linked list. Like we have solved in other yesterday's problem as well, we have to return the head of the linked list, because head of the linked list gives the correct direction of the linked list. So we have successfully solved this problem, but I have missed one thing. Is like whenever we are doing the reverse over here, we have also made a reverse function. So let's analyze the reverse function. It takes a node as parameter. Then it takes previous and current node. Previous node is set to null, and the current node is set to the temporary node, which is written and taken as parameters. And there is a node next. Okay. Now we are going to run the loop until it becomes 0. Next equals to current.next, stores the next position. Current equals to previous, reverse the pointer to the previous. Previous equals to current, move the previous pointer to the current, and current equals to next, move the current to the next, and return previous. Returns the head of the linked list. So this particular function you have to learn by heart. If you don't know the reversing of a linked list, you will face this problem in many other problem statements. So reversing of a linked list, you just need to remember this function how it's made. We have to take, always in the case of linked list, we have to pass a linked list node as the parameter. We have to take three nodes. We have to take three nodes and initialize them. Current denotes the node which is taken from the parameter. That's why it is saying it is equals to temp. Previous node is basically the null node. And while current not equals to null signifies that while current, like, we have to traverse the pointers and reverse it. So the current value cannot be null. Whenever we are saying that's null, means there's no value left in the linked list. And next equals to current dot next. It is to use to store the next node. Current dot next equals to previous. We are using the previous pointer to previous node. Pre equals to current. Move the previous pointer to the current node. And current equals to next. Move the current pointer to the next node. Return the previous. So whenever we are doing all these operations, just remember, just go through any good available websites of reversing a linked list or things like that. It will surely help you. Thank you. Have a nice day.